Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. So, in our last lecture, if you recall that we have discussed about descriptive statistics, and also we came to know that how to represent the data after processing of data, after interpreting, how we can take help of descriptive statistics to convey our findings, the very initial findings before really going to the detailed statistical analysis. Now, at the same time, like it is also important how to represent the data. That's why in the last lecture towards the end of it, I mentioned that in our upcoming lectures we'll be discussing on how to represent the data in a graphical manner or in a tabular manner or in a spatial manner subjected to the requirement, and then probably based on your research need or based on the type of information that you want to showcase, we can choose any one of them, or maybe we can take a combination of them to put in our research writing. So with that, today and the next day we'll be discussing about this data representation. So with that, today we'll be starting about the lecture 34, which is representation of data and inferences. Today we'll be discussing the part 1 of it, and then we continue with our next lecture with the same topic, that will be part 2. So let us understand the content of this presentation. So in this lecture we'll discuss about the data representation and its importance, and then the inferences that we can draw out of it, and we'll mainly focus on the graphical representation in this particular lecture, and remaining type of representation will take in our next lecture. Now, what exactly the data representation helps in our research? That it is converting the data into suitable form for analysis and understanding of the phenomena. It may be simple frequency, it may be a correlation, it may be a cross tabulation. So, there are different way you can present your data set. It may be the raw data that you collect, or maybe it is the processed data. If it is analyzed data, how to write those findings in a suitable manner. You can represent the same results in multiple way. You can take help of some graphs, or maybe in some cases you can also use the tables to say that. But at the same time, as researcher, you should also focus that what kind of representation can better represent the data set, so that it will be much more appealing to the readers, and then it is very easy to understand from those kind of representation. So, it also facilitates the understanding of the data, the processing of data, like to apprehend the data, and then a clear communication of the information or the data. Broadly, if we classify the data representation, we can represent our data in a graphical form, in a tabular form, and obviously when we are discussing about the planning aspect, planning and architecture, so how can we ignore the spatial representation, which is also very important nowadays for such kind of research where the spatial analysis is involved. And then the textual representation, many a times with a very brief and to the point text, we can also represent the data. We will take up certain examples, very basic examples, some of them from planning and architectural point of view, some of them is very general to make it easy to understand, but you can also correlate with the findings that you have, and then you can take a call which kind of representation better suit your result. Moving ahead, as already I have mentioned that in this presentation we will be focusing only on the graphical representation. So, these are the common representations and the graphs and chart, maybe you are familiar with all of them or maybe some of them. Let us discuss one by one and try to understand the importance of those graph, and also along with that I will give you some sort of tips like some do's and don'ts to deal with this kind of graphs or bar chart. So, it is like a bar chart, it can be a pie chart, it can be a line and area chart, it can be histogram, it can be a box plot, it may be a scatter plot, heat maps and many other types. Nowadays, this is the time where you have multiple resources. There are open source softwares which can very easily create those kind of infographics where the information is representing with certain graphical form, right. But mostly used graphical representations are listed here, and I will mention about some of the new one, and you can search little bit more on that, and then you can see that how those kind of graphical representation that you can use in your research. Coming to bar chart, it is very simple. Use of bar chart definitely for comparison of quantities and frequency across different categories, right. And in this case, the only design tips is keep it simple, and please you have to label those axes, right. So, definitely in this case these are all two dimensional plot. So, you have x axis and you have y axis. So, that should be labeled effectively. So, this is one example, a hypothetical example where it is something like the title of this bar chart is top 5 most visited architectural landmarks, and then it is basically representing the annual visitors. So, in your y axis this is the visitor, and all this quantity is that to the power e to the power 7. So, definitely some cases you cannot really represent your all these points in actual values. Sometimes it may be in thousands, sometimes it may be in millions, sometimes it is in you can say in lakhs. So, here in this case, like you can always represent it and you can scale that particular axis accordingly. And then in x axis these are nothing but different places like Eiffel Tower, Great Wall of China, Taj Mahal, then you have the Colosseum, and then Statue of Liberty, and then the title of this particular x axis is landmarks, and these are different places to be considered, and these are top 5, right. So, there might be other places as well. So, choosing about these names is just random. There is no such kind of correlation, or you cannot just say based on certain actual data. So, in this case definitely to help you understand this particular use of bar chart, I have created this. In this case also sometimes we may do some mistake. So, better like sometimes you have to like take care of that particular scale. So, many a times like it can be like having a clutter and misleading scale. So, for such kind of cases you have to be very much careful. Say for example, if you have those values in say in lakhs and millions, unnecessarily this will take long space, and then probably based on the actual scale it will look something very odd, gigantic, or in some cases probably you miss out certain critical information. So, there are options very easy, like most of you probably you are using Excel sheet for creating this, but there are other software. Any statistical softwares will have this option to create the chart and all. Nowadays also there are some open source softwares which can also help you to create charts effectively. So, in this case it is the bar graph depicting the annual visitor numbers for top 5 most visited architectural landmarks. Each bar represents the number of visitors as each site, providing a clear comparison across these popular tourists. So, out of that inferences that Great Wall of China is the most visited one, followed by Taj Mahal, then the Eiffel Tower, and then in this top 5 the 5th one is Statue of Liberty. Again I am telling you that there is no intention to showcase something high or low. This is just for understanding. This is one of the hypothetical examples that I have picked up. This is very important about understanding what to do and what not to do, okay, with the bar chart. And other representation, definitely the bar chart can be like this, where it can have a vertical bar, or maybe it can be a or horizontal bar. So, depending on representation, better representation, you can take any of them, right. So, in this case the upper one is a horizontal bar, it is a vertical bar, and each bar is representing only a single data or frequency. Similar to that, there are certain kind of stack bar. So, where in that particular case you have some sort of other representation. So, say for example, in those cases a bar can also have distribution. So, this is a total bar is say 100%, and within that you want to showcase different percentage like 25%, 25% or like that, right. And in this case another important part is that what kind of information that you want to showcase. Like in many cases, like along with this particular bar chart, we also use certain sort of legends when it is like very complex, or maybe the number of bars are more, or there are certain kind of comparison. Say for example, if this particular graph is for a particular year, now I want to make a temporal change for this top 5 most visited architectural site. I want to compare them in this particular time gap. So, 5 years. So, for that each of them will have say 5 years data. So, sometimes within that probably this is 1 year. In that case, if I try to make it, so for say this particular single location Eiffel Tower, we have 5 data points. So, in such cases, right, it is better to represent those kind of years by certain legends, right. Now, coming to the do's and don'ts, in this case use uniform bars width, so that this should not lead to any bias that some of the bars are having more width. Is there any other meaning of that? So, it should be uniform, and you have to label the axis clearly, what x axis means, what y axis means, and with a proper title of this particular bar chart, and then give a descriptive title. Nowadays many research journals, they also ask that you give certain sort of description along with your title caption, that what it represents, so that it will make some kind of sort of clarity. If somebody will only look at your graph, can get certain idea, right. At the same time, what you should not do, you should not skip the label or scale. Very important, scale plays a very crucial role. The earlier data, if we go for a without scaling the data, and if it is in millions, so maybe the figures will look different, distorted or something. Then unnecessarily do not use the 3D bars, which are nowadays maybe looking good, but that may give some sort of distort perception. So, that should be avoided, and unnecessarily do not use too many colors to make it beautiful. So, it is much more important to make your graph readable, comprehensible, rather than just making so many colors to assume that okay, it will look beautiful if we use multiple colors. Coming to pie chart, it is very commonly used, where it is showing the composition of a whole. So, within a particular data set, if you want to take the percentage of any component with respect to the whole, this is the best way to present. So, here it is again, each slice is depicting one particular characteristics or one particular group or one particular category, and then its presence in the overall scenario. Say for example, here it is again a hypothetical pie chart being created, where the proportion of total tourism revenue by architectural tour type. So, if we say architectural tour type, like for only visiting the historic castle, or it is something the modern skyscraper, or it may be the ancient ruins, or it may be a cultural landmarks and the nature and architecture. So, among all of them, it is very much evident from this particular pie chart that 30% okay, revenue are generated from this particular ancient ruins. So, again it is something like just for a practice purpose, just for understanding purpose, we are using this kind of random data. It may be in real scenario or for a context it may be different. So, maybe in some particular country the historic castle can contribute to even much more higher than what is represented here. Okay. In this case the limitation, it is really hard to compare the segments and it is based for few categories only. So, say for example, within this if we have certain more category, like in historic area if you have some more category and something on certain kind of typology and architectural style, then it will be very difficult. So, those kind of segment, even if nowadays people are using it, but many a times it will become very tough to represent. In such cases, it is better to represent those case in a form of table, or maybe you can go for a stack bar where you can showcase the composition within that. So, the main bar is showing this particular broad category and then subcategory can be presented within that individual bar. For pie chart, again the limit the number of slices. So, 2 to 6 categories is good. In many times it may happen, like suppose if the percentage or the presence of any particular label is very low, okay. So, then it may be just close to 0% and then it is maybe 0.03%. So, it is almost 0. So, in such cases like it is very difficult to present with this pie chart, and it is only good when you have certain kind of representation, at least you can see the slice effectively. Then order slice logically, that is up to you, that maybe if you want the reader to follow, you can arrange it based on the highest to lowest percentage, or maybe alphabetical order, or it may be something if you want to showcase certain kind of variables or some category where already it is having certain kind of coding. So, based on that also you can do. So, depending on the need you can do. Use contrasting color for this pie chart, and you should not use and don't go for something like a monochrome. So, in many cases what will happen that those colors cannot be very easily identified if somebody is having color impairment or something like that. The difficulty in the color identification is basically you have to give a contrasting color, or else you go for some sort of hatch pattern. So, earlier if you see that the researcher used to make those kind of pie chart with certain kind of hatch pattern. So, in those cases like it is very easy, even if it is in black and white. So, those are very easy to identify. Now, don'ts, in this case do not use it for the complex data. In that case you go for alternative options, and then do not overdo the effects, avoid excessive use of shadow and then also the 3D pie chart etc. for scientific writing, and label all the slides properly. In many cases like you can write the information within that particular zone if the size of the pie is good enough and the text size is legible, or else you have to use again the legend. So, in legends you can write down the meaning of those color and which group it belongs to. Coming to the next category, here it is the line and area chart. So, for normal continuous data and all, this is very useful. So, this is helpful for displaying the trends over time. It helps in understanding the comparative growth as well. Whenever you just try to understand, like say population growth. So, you just take y axis as population and x axis as your number of years, like say 2001 to 2023, if you have some year wise data for something. So, you can take those points and then you connect it. So, maybe there is a graph like this, or maybe it is something also declining, or maybe it is not regular. Okay. So, there is a drop. So, the best example you can take if you take information for the precipitation or such kind of temperature etc., where you can see the changes, or it is something again similar to the ECG, that where different nodes are captured along the axis and with the time, and this you can represent with the area. So that this is something you can also substitute this particular area with this area to see the difference at that particular time, and also like this is showing you the trend. Another good example I can give you at this moment, if you love to see the cricket match and all. So whenever they are showing this kind of the scoring pattern or the run chase map, so there you probably can observe that in x axis they are giving the number of overs and this is the run. So maybe the first team scored something like this, and the second team maybe started high, then low, then maybe this is something is giving you some comparison that each overs what are the totals they are making. So this is nothing but a cumulative plot. The data can be represented with a bar chart as well, where each over how many runs are scored. So like that you can use this line and area chart effectively. So in this case also the hypothetical example taken the trends in tourism growth over 3 years in different region, and for that different shades are taken into consideration. So in this case Asia, Europe and America, so these are three broad areas, geographical area considered, and from 2010 to 20, and here you can see that the maximum growth happened in Asia, followed by Europe and then the America. So then you can effectively use the legends to represent it. Moving to the do's and don'ts. So for line, use solid and contrasting line. You can go for certain other type of lines, a dot line and all. So those are for the trend and other thing, but normally you use a very legible and contrasting color lines to differentiate and limit the number of lines. If you take so many information, so there will be overlapping and it is very tough to record. If there is no such kind of variation available for certain data type, and then you can find that all lines are very nearby. So it is very tough. In that case probably you go for a table. Use marker for data points. If required you can also use the marker. So markers are nothing but those kind of point corresponding to the y axis. So you can use those kind of point for better readability. Don'ts. Don't overlap lines unnecessarily, and that is definitely whenever you have data sets for different findings very close to each other. And please don't ignore the trend and pattern, because this is something the main purpose of using this graph. So that you need to take care. Don't make lines too thin or too bold. If it is too thin, maybe in a printable format it is not very much legible. If it is too thick, then probably it can, if the lines are too close to each other, then it can go for some sort of overlapping, and then that will not be good for a reader to read. Coming to the histogram, in this case it is also showing the frequency point that we discussed last class also, that it is showing some sort of hypothetical example, again the distribution of building ages in a historical district. So where the buildings mostly like 75 to 125 you have the maximum distribution, and then there are other few as well. So in this case definitely, which is very important to understand, the bins or the ranges. So then decide upon that 0 to 25, 25 to 50. So it is very uniform bins that have been created. So last class also discussed about the ages, like that it is less than 20 years or 20 to 40 years, 40 to 60 years. So like that we can decide those kind of ranges. Then the shapes may be symmetrical or skewed or multimodal. So that also we discuss about whenever you go for descriptive. So if the data is uniformly distributed, so it is very much symmetrical, but it may be skewed also, like it is maybe left side skewed or right side skewed, or maybe it is having multiple modes. So, the data is not giving you a particular number or some kind of central tendency. So, in those cases you can have multimodal as well. For do's and don'ts, it's choose appropriate bin size, because this should not be too narrow for distinguishing the difference, or it should not be too big. And in this case definitely you should give the labels axis very properly, so that this kind of frequency and the bins can be easily identifiable. So, say for example, if it is the age group, so 0 to 25, 25 to 50, 50 to 75 and more than that, or maybe you can change accordingly. Use consistent intervals, that will give you a better representation. Do not leave gaps between bins, so there should not be any missing data in between. Do not ignore outliers. So, this is something last class we discussed, that some of the data points, they are not really matching with the other data points, or their behavior, their cumulative effect, or the you can say that their average, it is too away for that particular average finding, or the central value. In such cases also you should not delete it unless you just identify that there was certain mistake in data entry or maybe in the data collection, because that can also show some sort of actual representation of population. So, you have to keep it. And also do not use non-sequential bins. So, then it should be in sequence. So, it should not be haphazard, so that it can represent it well. Coming to the box plot, so here also these box plots are used to compare the spread and centers of distribution that we discussed last class. So, maybe here we just quickly go through it once again, that here we have certain important points like minimum value, maximum value, and within that we have the lower bound, that is called first quartile, or maybe this is also referred as a 25th percentile. Then you have median, and in this case normally it is the 50th percentile. Then Q3 is the upper limit, and then we have this whisker to represent those kind of max. And then there are also some kind of other points which considered as the outliers. So, for that outliers, this is normally to be visualized with whisker or the points. Now, in this case, this is again some sort of hypothetical example, the box plot illustrating the hypothetical range of hotel prices in different tourist cities. So, say for example, in Paris there are multiple hotels, different depending on the facilities and all, the price may vary. So, depending on that, this is what it is the minimum price, where compared to that in Tokyo the minimum price is quite low, and you can see that in this case, like even for this kind of Cairo, the value is even lower, even the highest value is almost compared to the 25th percentile of Tokyo, it is even below that. So, on an average, if you see that the cost of hotels are very less in this. So, you can identify this kind of findings. More importantly, this will also tell you about the overall distribution of the data. So, whenever you can see that overall box plot and this whisker plot, that in Cairo the variability is very less, that is the range between the minimum and maximum is very low compared to that of the New York City. So, where it is varying too much. So, you have very high end hotel where the range is too high, and also you have comparatively lower than that. Now, compared to that, the Paris, in this case the base level, even the lower level is not that low and higher level is not that high compared to the New York City. So, then it is something the dispersion is less. So, the minimum dispersion we can observe in Cairo, but maximum dispersion in New York City. So, like that, whenever you try to compare different group and try to compare the range and different quartile and identify the median. box plot is the best to represent. But we have to select that whether this is required for my data or else simple frequency bar is good enough, because interpreting this data, you have to understand the audience where you are publishing it. In a scientific journal probably it is okay, but if it is a common findings that you want to publish something as a overall news bulletin or something, probably it's not very easy for the readers to identify unless you explain it. So, for box plot definitely you should show the outliers, because they can provide some important information about the variability, and then also you should label the quartiles and the median effectively. Use side by side box plot for comparison in the way we have shown for the different city, the rent of the hotels for the tourist cities. Accordingly, like you have certain other points that you don't ignore the context, understanding what each quartile represent in the interpretation. Don't use without understanding the audience, because box plot can confuse readers about all those values. And don't forget the scale, because this is very important, at what scale you are comparing, right. Coming to the scatter plot, it is another representation, and normally it is used to show certain sort of correlation between two variables, right. It can also show you the pattern. Use different color and size for better representation, and these are nothing but the points, these are the coordinates. So, say for example, here again it is another hypothetical example where x axis represents number of tourist attraction, and then it is something attraction points, and then this is the average daily visitors in thousands, that is given like 4,000, 6,000, it is in actual, right. So, for that, from this particular plot, it is obvious whenever you have more sites of attraction in a location, then people will stay little more, okay, and they can visit in your city. So, that there is some certain sort of increase. So, again this may not be a true case, some places maybe all those attraction points are nearby, somewhere it is dispersed, but to understand that in order to establish any such sort of relationship, you have to use this scatter plot. I cannot say you have to, means you can use it. The scatter plot use different colors and markers for different groups. If you have multiple scattered to plot over there, label the axis with the units, very important what unit you are using, include a trend line if possible. So, say for example, if there is some sort of data point and all, the scatter plot, and you try to plot the linear equation, which you can again see that some of the lines are points are not on the line, there is certain sort of deviation, but still it can fit. Or maybe you have a graph where you have this kind of scatter plot, so where you can join them with a particular trend line. Don't overplot too many points, can confuse this particular plot, so don't do that. Then in this case, don't ignore the axis scale, and then don't forget to check the patterns or the cluster if they exist, right. So, heat maps, this is another way, and this is something we can use it to visualize the matrices or tables. It can represent the value, and it can be used for geographical data or correlation matrix. So, in this case it is something that this particular example is taking the heat map of tourist foot traffic in city areas. So, this map is divided into grid with each section representing an area of the city. The color intensity corresponded to the foot traffic density, where the warmer color, if you see from this, like when it is close to white, it is having the highest value, and close to black it is going to be the lowest value. So, the color bar on the right provides the scale for interpreting the traffic density, that how those areas are filled. So, this is another heat map, there are multiple uses of that. In this case, use clear color scheme so that there should not be a confusion, include legend for understanding the scale, arrange the data logically. There should not be any such kind of other values which cannot be considered in this particular graph. So, first check the data which you need to put in the heat map. Do not use overly similar colors, that may give you confusion as well, and do not clutter with too much of information. So, that is why I mentioned that you should check the data that you are going to use, and do not ignore the missing data, because be aware how missing data is represented and ensure it is clear to the viewer. So, that is very important. So, coming to end of this particular presentation, hope it was a very detailed explanation of different uses of different graphs, the graphical representation. So, that we discussed, and in this case definitely we got to know about the use of those kind of graphs, and there are certain limitations, and where you will use the box plot or where you will go for the histogram, depending on the need you have to select. So, with that I end it here. So, remaining type of visualization like the tabular or the spatial or the textual we will be discussing in our next lecture, which is the part 2 of this representation of data and inferences. So, thank you for joining. We will be meeting in our next lecture soon. Bye.